Oh, g'day champions, we're in the home workshop today. Got a couple of Martins here, you can see there, neck resets. Got the coffee machine over here warming up, not because I need an instant caffeine hit, but reasons that will become clear soon. So this one here, I've adjusted the neck as straight as we can get it, and on the treble side there's a slight back bow, and on this side there's a slight relief. So I've got it averaged between the two, so we're sort of as small back bow as possible and as small relief as possible, and balanced between the two. So it will require some fret work, but we are also removing the neck and we're going to change the neck angle slightly. So we'll be changing the shape of the frets, particularly in this area. There'll become a little bit of a hump there. At the moment there's a dip because the neck's like on the wrong angle. So when we put it back, it'll be straighter than it is, but it will still require some fine tuning, and while we're at it we can take out this slight twist that this neck has as well and get it playing like a beast. So it may be a little bit hard to make out here with the lighting, but we're at over 3.5mm on the 12th fret on the 6th string bass side, and then on the treble side we're about 3mm. So that's on the high side. Some people don't mind it that high, but if you're playing intricate finger picking style stuff further up the neck, it gets a bit laborious to fret the strings. And up here at the saddle we've kind of already got the break angle that we're after, so we don't really want to just go filing the bottom of the saddle down in order to lower it, because you'll start losing down pressure and the strings will move around, the pickup will sound dead, you'll lose resonance, a whole bunch of reasons. Now I've seen some people just take like a belt sander to the top of the bridge. Don't do that either, please. This is like a synthetic Laminex type material for the bridge. It's not timber, so you'd have a hard time sanding that anyway. But yeah, that's not the way to fix this problem. Now I'm not sure what it is with Martin owners in particular, but I'm not saying that's the case with this bloke, he's cool, but people will buy these things when they're unplayable, just to have a Martin, I guess. I don't know. And then they'll bring him to me. I'll have to break the news that it needs a neck reset in order to have decent playability. And it's sort of like disbelief there. Like, how could Martin do that? They're Martin, you know? I don't know the full story as to why this is a thing. Martin and people on Martin forums, Martin apologists, they say, oh, that's just how they are. You just don't understand them, or some equally preposterous bullshit. Having I've had them as high as 4.55mm at the 12th fret, and that was a new guitar, like under warranty still. Got sent back to Martin, or their local distributor. They looked at it, said, nothing wrong with it, it's fine. People will buy Martins because it says Martin on headstock, and then they'll deal with the problems later. So I've noticed some of these going for, well below market value because the action's so high. And some of the retailers are taking a hit on it too. They buy one and they can't make any money on it because they've got to discount it so much that someone will buy it, despite barely being able to play past the 7th fret without intonation going out. So when you're moving the string that far, you're introducing a lot more tension there, so it goes sharp when you're playing on the 12th fret. Now, if you were to not do anything to the neck, you'd have to move the saddle back, like on an adjustable intonation on an electric guitar. Like if it goes sharp, you move it this way. If it goes flat, you move it that way, right? But what we're going to do is change the angle of this neck so there's less down pressure, and that usually sorts out the intonation issues as well at the same time. We're already about as low as we can be at the nut. It's got a nicely fitted bone nut there, so there's enough movement there that when we do straighten it up, we can fine tune those slots. We can go a little bit deeper to get it nicer. It's a little bit of a step there. I'm not sure if the top veneer has shrunk a little bit, but yeah, there is a little step there in the binding, solid timber binding. And just looking closely, looks like that peghead veneer is actually separating right near the nut there. There's a little gap under it. It's like they've jammed the nut in there a little too tightly in the factory, and that's at the action of lifting up that veneer. So we might have to remove the nut, shave it down a touch, glue that back down, and just clean it up before reinstalling the nut. You can see the frets are just very corroded as well. Hasn't been played much, particularly not up here. You can see they get a little bit less corroded down near the nut. So anyway, we're going to give it a fret hone, and they'll come up like mirrors once we're done as well. So yeah, I'm not sure what the story is, why this keeps happening. Looking at this, the neck angle is a little bit off as well. There's actually more, that string's almost right on the edge of the fretboard, and this one's probably 5mm in from the edge. So if we can assess that while we're adjusting the heel joint, we'll just angle the neck ever so slightly this way, that way to address that as well. So anything we can do to improve it in the process. Right, so before cutting the strings, I'll just ease the tension off a bit so it's not as violent when I do cut them. They don't go flying. Just doesn't feel right when you do that. Like explosively cutting them. I've got my hardened steel cutters here. If you try to use anything meant for electronics, and you just destroy the blades. Each string leaves a little notch in the blade. Just put a business card under the bridge. Gently take the pins out. I'm not squeezing the pliers, I'm just using them like a fork. Most of them come out with no force, particularly the unwound ones. Alright, so essentially we've got two glue joints here. We've got the tongue of the fretboard glued to the face of the soundboard, and we've also got dovetail down inside here, which you'll see later on. Now the dovetail is dovetail shaped. It reaches just before the 15th fret, sorry. So there's a little void at the end of the dovetail, and we want to get our needle down into that void in order to steam that joint open and be able to gently remove it. But obviously we can't remove it until we've unglued this whole area. So the first thing we've got to do is heat this area carefully, only this area, and we've got to pry this section off the soundboard carefully without ruining any of the timber fibers before we can work on the dovetail joint. We've got to think about it in two parts. Do this one first and then work on the dovetail. In order to gain access to that joint, we've got to remove this fret, and we can hide our holes underneath that fret, so when we reinstall it, there'll be no evidence that we injected the steam into the joint. So first thing, I'll scribe it, just so no fibers get lifted when we remove the fret, particularly in the binding in this case, because it is that tech wood or whatever it's called, the phenolic resin essentially. I'll get my fret end nippers, just grip it and gently lift the very end, and then work our way under the fret, starting from one end, working our way across. That came out relatively easily, indicating that they probably didn't use any glue. Now we've got access to that end of the dovetail joint. If we drill two holes there, 2mm holes to suit the needle on the steam handle. I should also note that this is not your traditional dovetail joint. It's got a bolt as well. Now that's not really adjustable because the glue is obviously set in the dovetail. I think it just aids them with ease of assembly on the production line, and they've covered that bolt with this little badge here, which is on a piece of timber that's just glued to the neck block. So we've just got to carefully remove that to get access to that bolt before we can remove the neck. And to do that, I've fashioned this tool out of a 25mm hardware store scraper. I've heated it up with the gas torch and given it this shape. It makes it good for getting under stuff and prying it through guitar sound holes, that kind of thing, and just scraping glue off bridge plate joins, that kind of thing. And there's the plate. It's actually foam tape that's on there, so it's pretty easy to remove. I thought they had a dab of glue. I think I've encountered that once before, but either way you can remove it without too much trouble. It's got a laser logo there with a serial number. I probably shouldn't show you. It's too late. You can see in there the large pan head screw with the star washer underneath it. So here's a look at the slightly janky looking setup to remove the neck, or the fretboard tongue from the soundboard. just got some sanding blocks there, radius blocks. There's the heating blanket with the control unit from LMI, Luthiers Mercantile International. And we've got our fretboard removal blanket. So these things aren't cheap, so I got a couple that do a few different jobs. Instead of getting the fretboard tongue removal one, which is only about that long, similar shape, width, but just long enough to do that one job, I just bought the whole fretboard removal one, and I can use it in this configuration for just removing the fretboard tongue from the soundboard. So I got it set to about 110, 120. You can see the ambient temp there, 14 degrees Celsius. So we'll flick that on, keep an eye on it, never leave this alone. Always be next to it, constantly monitoring it while you're doing it, because the danger that something goes wrong, all it takes is that thermocouple to fall out, and the thing will just run away and cook itself and probably set fire to itself. So that goes in there. That's the sensor. We've just got that sitting in there, a little bit of tape just keeping it in place, and that will give us an accurate reading of that area of the blanket. And we've just lifted it with another sanding block so it doesn't affect the rest of the fretboard. That's enough of isolation there to not be an issue. And let's fire it up. See the temp starting to rise. Now there tends to be a bit of inertia there because the block's cold, so the blanket tends to overheat. So I manually switched on and off a few times as it's just been turned on, and just let the thermal inertia catch up. When it slows down and starts to go down again, I'll flick it back on, just so we're not damaging the rest of it. It's getting warm. I can keep my hand there for about 5 seconds. That's probably about 60 degrees at the moment. Yeah, 65, 67. So we'll just flick that off again because it's rising rather rapidly. Alright, so it's starting to settle down there, about 1.9, there we go, 110. So that's reached equilibrium. So we may as well take advantage of the hot element and warm up our palette knife that we're going to separate this join with, and leave this for a while, of course monitoring it, not letting it out of our sight, just keep an eye on it, and we'll come back when she's ready to start prying apart that fretboard. In the meantime, got the Expa bar here, office lever. It is the main reason I get out of bed in the morning. We've got the steam for steaming the milk. I'm going to take that nozzle off, the nizzle, take the nizzle, put on the hose, and get it ready. Alright, so we'll just test that our hose isn't going to blast off. The last thing you need when you're working on the guitar is for that to explode off and cover you in steam. Just got the needle going down into a bucket there. Initially the steam will condense because this hose is cold, so you'll get water for the first while. So you've got to turn it on gently and heat the whole hose up before you start getting steam out. And even then, if there's any dips in the hose where water's allowed to collect, that will collect, and then it will build up, and then it will blast out as a big jet of water. So you want to avoid that. We want to put as least moisture into this thing as possible. There's going to have to be some inevitably. Alright, we're starting to get steam now. You still see it's dripping a little bit. That's about where we want it. The tap's only just turned on. And if I drop this hose, a big jet of water will come out of it. Like so. So you want to do it in sort of fits and starts, so you're not blasting a big jet of water inside the dovetail joint. You just want steam. Anyway, we've tested that, that's good, so we'll just let that stay warm until we're ready to rock. Alright, so we've had that on there for about 45 minutes, sitting at 120. Just remove it, have a quick feel inside. When you feel the block underneath starting to warm up, we know that we've got some decent amount of heat into the joint, and we can start seeing if we can separate it. Alright, so carefully I'm going to start from the end. I'm starting to be able to get in there okay. This is the time consuming part, you can't rush this part. Alright, we've got full separation there. Now we can drill our holes and start steaming the joint. Right, now here we've got the guitar upside down with the neck coil on there, clamped in the bench vise. Because when we inject the steam, we don't want it running down into the body. If anything, we want it coming down the neck where it can be easily cleaned up. We want to try and reduce the amount of moisture and humidity that we're actually putting into the body. So this will allow any excess water to drip downwards, where we can just put a towel around there and clean it up. Alright, we've got our Stumac neck jig in place. It's a bit tricky because all the literature about these things shows a guitar with no cutaway. So when you've got a cutaway, you miss the cutaway. So I might put another little block in there with some cork to just reintroduce some pressure in this area. Alright, so that's installed. Sorry about the shitty light, it's not great in here. I've got a cork block in there to fill a gap because the block there that normally touches the body is missing because it's cut away. We've got like a spreader on there which they supply with it. It's laser cut acrylic. That stops these from spreading out, or I should say an anti-spreader. So these screws here, because the back's bowl, like it's got a radius to it, they're naturally going to want to push outwards, so that stops that from happening. You've got some protection tubing there which stops it from marring the finish. Johnny marring the finish. So I've taken up the slack with the tension screw down here. There's a little protection piece of acrylic on the heel, and just got a bit of preload on there, just like barely any, 2 fingers. Now we know everything's home and nothing's moving, everything's tight, so that's good. So now we can start with the steam and give it a little bit. We'll give it a pump of steam first just to get some moisture in there, let that settle in, distribute the humidity within the joint, and then give it a little bit more and see if we can start getting some movement. But again, you can't rush this. It takes a while for that glue to soften up, and yeah, if it's not easy to take apart, you're going to damage something. So you need to give it enough time for the moisture to get into the glue, and it should come off very easily once it does. And if you've got to force it, something's wrong. It's a little bit like mechanics, really. If you've got to force something, you've missed a bolt, you've forgotten about a gasket, or you know, you've done something wrong. So stop, reassess, otherwise you're going to break something. And that is a lesson that you'll always learn the hard way. You always disregard what everyone says until you've learned it the hard way. Then you tell someone else and they disregard it until they learn the hard way. Yeah, it's the story of life. So we'll start the steam. Got my pressure gauge there. It just drops down about 2 notches when you open it up. If you go too far, you might blast the hose off the end of the nozzle. We're mainly getting water out there now because the hose is still cold. That tube's warming up now. There's mostly steam coming out. The occasional blast of water as it's still warming up. Alright, wait for a little burst of water to come out, then we'll go for it. Then we'll go for it. You can see it coming out the other hole. That's good. Just give it a minute. Not a minute, give it a second. Let the water out. And go again. Go in the other hole. Let the water out again. Yeah, it sort of sputters there. This is good. Much better results with a lower pressure, just by turning the outlet down. I'll turn that off for a minute, and we'll give it a while to just work its way in. Might have to go make a cup of coffee. Sorry, I'll make a cup of tea because coffee machine's predisposed. we'll start introducing a bit of pressure. Easy does it. Starting to see a little bit of movement. Not moving it much, it's only like holding it with my fingertips, not leaning on it. Oh, I've got about a millimetre under the fretboard now, so it's starting to go. Surprising how long it holds on for from past experience. Like it'll be like 3-4 mil off and it still feels like it's glued. But that's not putting up much of a fight now, that's good, and that's what we want. Put a bit more pressure on, give it a wiggle. And you can feel the preload goes away, and then you put a little bit more pressure on, give it another wiggle. Alright champions, so it's a few days later. It's the earliest chance I've had to get back in the workshop since we steamed this neck apart. So the dovetail joint has dried out. So we're ready to start cleaning it up and prepping it for changing the angle on the back of the heel, and then setting it up and re-gluing it. You can see through there the hole for the bolt, and there's the void for the truss rod nut to pass, or the truss rod Allen key to be able to pass through and access the truss rod adjustment down at the end there. That's why you need a particularly long Allen key on these Martins. So I'll get to work on cleaning this up and show you once we're ready to glue it up in the next video. So thanks for watching, legends, and stay posted for that one.